All right, guys, we're going to quickly talk about unit vectors and how to like add and subtract them. This is technically 1.5b notes. Now there's no like special anything with this. I'm just going to write and talk here. And if you hear my dog howl in the background, Marvin's dreaming right now. So we're just going to let him sleep. All right, unit vectors. You should have learned from 1.4b or 1.4a. The basic idea behind a unit vector is instead of writing like your x and y components, so in AP Physics 1, we would have had like something like this, and it could have gone 2 and then 2, and you would have said that it had a velocity in the x direction of 2, and it had a velocity in the y direction of 2. Then you would have found out, okay, what is my hypotenuse? You would have said the velocity is the square root of 2 squared plus 2 squared, which gives me the square root of 8. I hope I do have a calculator. I was about to say, and I don't have a calculator, but we get the square root of 8 to be like, I don't know, 2.8 meters per second. That was AP Physics 1. 1.4b, we said, no. We can write this vector right away as 2i plus 2j. Velocity vector, done. No finding the hypotenuse. We don't need to bother finding the angle. We can just write that as our vector. So now I want to lead into, all right, so if we have like a vector and another vector and another vector, how can I add up the vectors? How can I add and subtract these vectors using this unit vector notation? So let's start by saying I've got, I don't know, let's say vector A is 2i minus 3j. Vector B is 4i plus 6j. And let's say that C is A plus B. If I want to find what C is, I'm literally just going to do 2. I'm going to do A, which is 2, plus this one, 4i plus 6j. And I'm only going to add my x and y components. So only the x components add, only the y components add. So I would get C equals 6i plus 3j, which if I were to draw that would be 1, 2, 3, 1, 2, 3, 4, 5, 6. Somewhere like if I started at 0, 0, it'd be like over 6 up 3. That would be vector C here. So the idea behind this is I can add up as many vectors as I want. I just need to make sure I'm adding the x components and I'm adding the y components. So let's try another one, but let's get a little more crazy. So let's say A is equal to 12i plus 3j. B, it's a terrible B, is equal to negative 2i minus 6j. And then we've got C here, which is equal to 4i plus j minus k. Ooh, K. Means we're in 3D. It's the Z component. Right now, we're not going to go too much into the Z component, but in the future, like so next quarter, like fourth quarter, we're going to go into this Z component. So we're going to start looking at 3D things, and we'll learn some nice tricky tricks with our hands to help us figure that out. And let's say we've got D here, and D is A plus B plus C. So again, we're just going to add up all of our x components, all of our y components, and then we've got a z component. So 12 minus 2 gives me 10, plus 4, 14i. 3 minus 6, negative 3, plus 1, negative 2, so negative 2j. And then we only have 1k, so we get a negative k. That should not be unfriendly. If we want to subtract it, it's pretty straightforward. We're just going to subtract them instead. So let's say A is equal to 2i minus 3j. B is equal to 6i plus 4j. And let's just say C is A minus B. So we just need to distribute a 1 and a negative into there. So we would get 2i minus 3j minus 6. Oh, that's supposed to be nice, 6i plus 4j. So in reality, we get 2i minus 3j minus 6i minus 4j, which gives me C equaling negative 4i minus 7j. And that's really all there is to this, guys. It's not supposed to be complicated. I was originally going to have us do some multiplication here, but I'm just going to have us do addition and subtraction of vectors. We'll do multiplication next unit. So that's it for adding and subtracting unit vectors. Really, the power is we no longer have to worry about our we don't have to worry about angles. We don't have to worry about that resultant value. Now, let's say it did ask me for this resultant value, and it's like, okay, what's the length of C? We would just do C is equal to our square root of negative 4 squared plus negative 7 squared. And we would just find that hypotenuse like we did last year. So you would do negative 4 squared plus negative 7 squared. And this would give me 8.06. I don't know what the unit is. There's no unit there, so we can't really throw a unit on there. But that's pretty much it. If you have questions, feel free to ask me in class, but that's the basics of unit vectors.